So now for this demonstration circuit, I have the voltage of the supply rails on display right there because that's what changes the output here. So I can fine tune it, and I did so to get the red LED to light up when we have about 11 volts, which we do there. Power supply says 11 volts, but we probably lose a little bit in the process. But in any case, I'm going to raise the voltage just slightly right there. Now we have enough voltage to turn the LED green. So our signal is actually coming from the voltage divider looking at the supply rail voltage. Our trim pot voltage, which I can adjust, but after that point it is set because we have a Zener diode parallel to it. So it's going to maintain its voltage, whereas as the supply voltage changes, our signal voltage is going to change and determine the output right there. So that's a good way to monitor whether the supply voltage is above or below a certain voltage. So now we'll look at the schematic diagram when we want a green LED to light up when there's enough supply voltage, and then a red LED to light up when the voltage goes down. So we're using an op amp, and we're using it as a inverting comparator. I'm using the LM358. So we have our I'm going to say fixed voltage here. Even though it's a trim pot, we can adjust it, but after that point it's fixed even as the supply voltage changes. So that's why we give our reference voltage to the plus non-inverting input. Since our signal is going to the inverting input, that makes it an inverting comparator. And we have two fixed value resistors, so you get half of the supply voltage no matter what it is. But we're looking at a supply voltage that changes, so the signal voltage is going to change. And when it has a higher voltage than we set there, we'll have a low output. And when its voltage goes down below what we set there, we'll have a high output. So now we'll take a closer look at our two voltages that we're going to compare. It's the op amp wired as an inverting comparator. So let's make this easy. We can set the voltage of the output of this trim pot anywhere between 0 and 5.6 volts. Let's do 5 volts. Of course, you need current going through there and extra voltage. So this is our reference voltage. It's set once we set the trim pot. So this is our signal voltage because the voltage of the supply is going to change. If we set this to 5 volts right there, then 10 volts is going to be the point where it changes. Below 10 volts, we'll have less than 5 volts here, and then we'll have a high output. Red LED will light up. If we raise this above 10 volts, we'll have above 5 volts there, which is what we set there. And then we'll have a higher voltage, which gives a low output. The green LED will light up to let us know we have a higher voltage.